Okay, question 16. The fundamental theorem of calculus tells us that for any polynomial f, dy dx of that integral, right? So technically it's telling you differentiation and integration cancels in some way, right? Equals to f of x. I mean, this is not hard to prove, right? This is, the simple proof is that, okay, if I integrate this, so this is d by dx, what? So small f integrates to capital F, right? So capital F of x minus capital F of 0. And we know that capital F of 0 is a constant, right? So that differentiates to 0 there. So d by dx of capital F is just small f, right? So that's the simple proof of that. So let's see what the student is doing. Okay, so it's a classic TMU question. Find the error in the proof. Okay, or maybe he's correct. I don't know. Okay, let's not make assumptions on this guy. So, so the student calculates that as follows. Okay, so line 1, what did he do? He separated the integral, okay, into two parts. That's absolutely fine, right? Because it's just the area from 0 to 2x minus the area from 0 to x. So that gives you the area between x and 2x. Fine, perfectly fine. Okay, so 1 is correct. 2. By fundamental theorem of calculus, d by dx from 0 to x, t squared dt equals x squared. Okay, that's a direct application of, of what they have given us, so fine. Okay, part 3. By fundamental theorem of calculus, d by dx of 0 to 2x, t squared dt is that squared equals 4x squared. Okay, that looks pretty legit. But you see in their thing is x and x here, right? So what this guy is doing is that this is x and 2x, right? So it's slightly different, right? So if you want to use the fundamental theorem of calculus, you're going to make sure that you somehow have to make a substitution or something, right? To make sure that this actually works, all right? Okay, so he might want to do this, right? So you're going to go d by d2x, right? And then, of course, you're going to multiply a 2 in front, right? Because you have an extra 2 in a denominator, so you need a 2 in front to cancel that. If he did this, and then he says, okay, this is 2 times 2x squared, then he's very correct, right? But he cannot apply the fundamental theorem of calculus when the scale of the variable, right? When the scale of the variable is not the same, right? You can't do that. Okay, so he has to adjust the scale of the variable. So he needs d by d2x here to match up with his 2x boundary here. All right, so therefore he'll have 2 times 2x all squared, which is 8x squared. All right, okay, if you don't believe this, okay, you can actually do the algebra. Right, okay, let's do the algebra actually, because maybe the scaling is hard to understand sometimes. So off we go. So this is 1/3 t cubed 2x 0, right, which is 1/3 2x or cubed, which is 8 over 3x cubed, right? So when you differentiate this, you get 8x squared, which is the same as what I have here. All right, so now we know, using fundamental theorem of calculus, we need the variables to have the same scale, right? It has to be the same variable. So line 3, no good. So option, which one? Option D, calculation incorrect, first error is on line 3.